Hi, everybody. Today we'll start a new chapter. It's extra chapter in your book, multiplexer. But before talking about multiplexer, we need to make some background for and what is Arithmetic Logic Unit, ALU, Combinational Logic, Sequential Logic, then transmission gate, to finalize to multiplexer designs. So before we know what is multiplexer, we need to know as a background, as a fast or review for other courses. So as a background, what is ALU? It's Arithmetic Logic Unit. It is a combinational digital electronic circuit that performs arithmetic and operation on binary numbers. So ALU بتصير الاوبريشن بقلبها، الارithmetic operations بقلبها، multiplication, division, subtraction, addition, and so on and so on. ALU today is inside the core CPU. Okay? It is fundamental building block of many types of computing circuits, like central processing unit, CPU, graphics processing unit, GPU. So inside the VGA graphics card, VGA video graphic card, there is processing unit called graphics processing unit, GPU. صار في مايكرو كنترولر او سي بي يو او بسموه جي بي يو بقلب الفي جي اي مشان يسرع الجرافيكس، وبقلبه هيدا في اليو ثانيه، في بقلبه ميموري وغيره. ناو شو بيعمل اوبريشن اي ال يو؟ الاوبريشنز كلكم تعرفوها از ريفيو، هي لوجيك جيتس، نوت، نيجيشن انفرتر، NAND and NOR or and XOR. اكيد في XNOR اذا بدنا. اوكي؟ هيدي الاوبريشنز يلي بتنعمل او لوجيك جيتس اوبريشنز اللي بقلب الاي ال يو. هلا logic gates that have an input and one output. اوكي؟ بنسمي هيدي logic gates لما يكون عندها n input، يفضل n bigger than or equal to 1. ما في n equal to 0 اكيد. Okay. Now, the new definition, unary operators. Unary operators means or have one input and one output logic gates. So unary operator has one input, one output, similar to or like an inverter. Inverter has one input, one output. Okay, called logic gates, but special word, it's unary operator. Now, what is combinational logic? Combinational circuit combine, the word combinational becomes from combine different logic gates in the circuit. So if you have in the same circuit different logic gates, we call it combinational logic circuit. For example, encoder, decoder, multiplexer, de-multiplexer, half adder, full adder, multiplier, and so on. Okay, so combinational circuit, it is a digital circuit that combine different logic gates. They have n inputs and m outputs, whereas logic gates has an input and one output. So logic gates, one output. Combinational logic circuit, no gates here. Combinational logic circuit, an input, m output. Many input, many output. Okay? The output at any instant of time depends only and only on the levels present at input terminal. So it's called time independent logic gates. Okay? Again. In combinational logic circuit, the output is depend on the input for each step. For each step, depend on the input. Okay? This is combinational logic circuit. They do not use any memory inside it. In combinational circuit, no memory. The previous state of inputs does not have any effect on the present state of the circuit. Okay? So, combinational circuit, the output is totally depend on the input and no previous state or memory or something like that. If we have, we call it sequential logic. Sequential circuit or logic circuit has a memory. Here we have, this is block diagram of sequential logic. Sequential logic means we have combinational logic circuit here, the output, and we have memory between output and the same circuit. If we put the memory, so it's called sequential logic. Here, the output will not depend on the input only. Here, the output will be depend on the input plus memory plus previous state of old input, new input plus old input. So the output will be depend on a new input and old input, or sorry, old output. Okay. So, for example, flip-flops, registers, counter, memories, and so on. So in memories or counter or register, flip-flops, they are sequential logic circuit. Okay? Any question? Any question? You will took these on another courses in your program. Okay? This is just a summary as a review in all computers or CPU or WhatsApp. Any question? Clear? Good. Now, let's go deep to the digital registers. Digital register, it is flip-flop. It's 1-bit memory cell. It's 1-bit memory cell. Flip-flop, it's 1-bit memory cell. We'll not talk about what is inside the flip-flops. It's for another course, okay? Just define. We define here some words because we'll use it later as a summary of all your programs or courses. So flip-flop, it is 1-bit memory cell, which can be used for storing the digital data. To increase the storage capacity in terms of number of bits, we have to use a group of flip-flops. So one flip-flop, 1-bit memory cell. I want n bit, so I will use n flip-flop. Okay? N number of flip-flops is known as n-bit register. Now, let's talk to another thing. Okay? What is pass transistor logic gate? PTL. Pass transistor logic gates. It is only one transistor that connect drain to the source. We have here drain, gate, source. So it's transistor. If it's on, then drain will be connected to the source. We assume it as we put on the drain input signal and the source will be the output signal. Okay, so output equal input when this transistor is on. But if we put always high volt on the gate, so this transistor is always on. Okay, so this transistor is always on. So the truth table will be for 0, okay, for 0 input here, sorry, here the gate is always on, okay, is always on. For input equal to 0, here the drain VDD here, the VDD is equal to 0, we got on output here strong 0 volt, because it's NMOS. In any channel CMOS, in any channel CMOS or NMOS, when we put on, do you remember the golden rule of CMOS technology? The golden rule talk about always we put N MOSFET to the ground, P MOSFET to the VDD. So N channel to the ground. If we put input is 0 here, so the output will be directly connected to the ground. So that's the main function of N channel. So will give us the output here will be equal strong 0 volt. But if we switch it, if we put on the input VDD here, if we put VDD 5 volt here, we have internal diodes inside the transistor and channel that reverse us to give us voltage threshold. We call it voltage threshold inside to be 4.5, not 5 volt. So we call it weak 1. So it's not exactly logic 1. It's not exactly logic 1. It's weak 1. So if we use this PTL gate just to connect input and output, we vary the input. Always VDD is here. The gate always has high volt. Here the gate has always high volt. So this transistor always on, but we switch, we vary the input. If the input is 0, the output is totally 0, strong 0. If the input is 1, 5 volt, the output will be weak 1, 4.5 volt. Okay? This is disadvantage, of course. We have this advantage. But they use PTL gate in analog signal, analog circuit, sorry. Okay, in analog circuit for high voltage. Okay? In reverse, if you have P MOSFET, okay, this is P MOSFET, always on, the voltage will be always 0 volt on the gate. The same. Here is the reverse. For 1, because P MOSFET designed to put VDD on it without loss. For 1, if input is high volt, the output is strong 1, 5 volt. But here, if the input is 0 volt, the output will not be 0. Will be added internal diode voltage threshold 0.5 volt, which we call it weak 0. Okay? Any question? Any question here? It's clear?
Yes, clear.
Good. Good. Again, I will repeat it in Arabic. على طول انتبهوا مني. هتشوفوا هذا السيركت، هذا ترانزستور اون اولويز اون، هذا اكثر شيء بيستعملوه بالكوميونيكيشن سيركت او انالوج سيركت، اكثر شيء بيستعملوه هون. بالديجيتال سيركت قليل استعماله، قليل لانه هو بالديجيتال سيركت استعماله بيعمل بريك اوت اوف ذا جولدن رول اوف سيموس تكنولوجي، لانه عم نستعمل اكزامبل هير، عم نعمل الانبوت هاي مفروض على الان شانل، الان شانل الان موسفيت always to the ground، والبي شانل always to the VDD. اوكي؟ ما فينا نقلبهم، بس هون بهالبي تي ال بينقلبوا، لانه الانبوت صار بطل الانبوت من الجيت، صار الانبوت على طول من الدرين او من سورس وات ايفر، من تيرمينال، بطل من الجيت، هون الترانزستور اولويز اون. اوكي، على طول شغال الترانزستور، عم نغير الانبوت بتغير الاوتبوت لانه هو بيعمل كونكشن. اوكي، بس في هون جوا internal diode. internal diode يا بيكون له تاثير يا ما له تاثير. عاده بالجولدن رول تبع السيموس، اذا ان channel على الزيرو no effect of the built-in or internal diodes. اوكي، على الزيرو no effect. so بيعطينا الاوتبوت equal input equal 0 فولت strong 0. على الان channel اذا حطينا الانبوت هاي فولت 1 صار له تاثير، الانترنال دايود انسايد ان شانل صار له تاثير بضعف لنا الاوتبوت. سو الاوتبوت هون بصير ايكوال انبوت او في دي دي او الهاي فولت ماينس ثريشولد فولت الانسايد يلي هي 0.5 فولت، بيطلع 4.5 فولت. اوكي، نحن ما عم نفوت بالديتيلز، ما عم نفوت لكم بالالكترون ديتيلز. اوكي، ما عم نفوت جوا، خلص جولدن رول احفظوها. جولدن رول، جولدن رول الان شانل على الجراوند، بي شانل على الفي دي دي، غير هيك بتصير ويك. اوكي، to be strong, to be strong design or CMOS technology strong design مفروض الان channel always 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 to the ground والبي channel always 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 to the VDD or high volt, else we have weak signal or weak output. okay, so بالبي channel العكس، بي channel معمول للفي دي دي، فاذا كان الانبوت هاي فولتج ايكوال في دي دي اوكي بيعطينا سترونج 1، else بيعطينا ويك 0 اذا كان 0، بس هون بلس ما في نيجاتيف 0.5 فولت. اوكي، واضح؟ جود. كرمال هيك اجت شيء اسمه ترانسميشن جيت. The disadvantage here, the disadvantage here, weak 1, weak 0 here, the disadvantage of PTL gate, they invent transmission gate that put N channel, P channel in parallel, same drain, same source. If we put it together like this, we put N channel facing to the P channel and same drain, same source, input output. So we combine the strong signal with the weak signal. Now the output will be strong. So for 0, strong 0 the output. For 1, strong 1. This is the advantage of transmission gate. This is the advantage of transmission gate. So transmission gate, it's a gate to transmit the output to the input. Okay, okay, this is transmission gate. So here the N channel always on, P channel always on. If we change the gate's value, so will not be transmission gate, we return to PTL gate. So the disadvantage of PTL gate, that output connected to the input in some state is weak, we have weak output. So we combine together, we put it in parallel, and they rename it to the called transmission gate. So to be always strong 0, strong 1. But this transmission gate will be always on. On N channel, always we put high volt. P channel, always we put low volt. Okay? واضحة؟ Okay. Now, the general view of transmission method, the symbol is, are the symbols. Similar to C, as you can see. So now we add a new variable. Input output, but we have C and C bar. Here we have input or C or selection. We call it selection, or control, C control signal. Here we want to control signal to turn on the transmission gate or to turn off the transmission gate. So we put C bar, because we have here P channel and channel. To turn it off together, two transistors must be turned off together or turned on together. Okay, ما فينا, we cannot turn it on one transistor and turn it off another transistor. We'll not call it transmission gate. We be in PTL gate. Okay, to avoid PTL gate, to avoid the disadvantage of PTL gate, it must be the input and input bar to be at the same time. Two transistors are on, or two transistors are off at the same time. Okay, if C0, if C equal to 0, okay, so any channel is off, C bar will be 1 for P channel is off. Okay, so any channel will be off, P channel will be off, then all transmission gate, which is combined of two transistors, are off, is off. So transmission gate is off. Here, because we have off, no circuit here, nothing here, output will be on the air. The output wire here will be on the air. It's not connected to the VDD and not connected to the ground. Yes, we call it high impedance. High impedance, high resistor, high impedance, Z. So it's a new terminology for you. High impedance means a wire in the air. It can be depend on the environmental electric field. It can be high impedance, it can be 0, it can be 1. Depend on the شو يسموه interference, what the air interference, حسب شو في موجود حوالي. Okay, so the new word here, high impedance, means wire, the output is on the air. It's not connected to the VDD and not connected to the ground. So this is called high impedance. This is disadvantage also for transmission gate, because if C equal to 1, the N channel will be on, C bar will be 0, so the P channel will be on. So the transmission gates will be on. So for C equal to 1, no error. It's correct. For C equal to 1, its transmission gate output will be equal to input and is strong. For 0, strong 0. For 1, strong 1. Okay? So here we have disadvantage on transmission gate when we have open circuit, when we have transmission gate is off, when we have C equal to 0. Okay? To avoid this, we need something else to do. Okay? We will correct this, of course. So again, as fast review for this, for any channel, always on in any channel here, always on. For input 0, output will be equal to input equal to strong 0. For input high voltage or 1, weak 1, the output will be weak 1. P channel, okay, it will work for VDD. For input equal to VDD, output equal to VDD and strong 1. For input equal to 0, which is not good design, the output will be weak 0, 0.5. To avoid this weakness, we create transmission gate. But here, the transmission gate must be always on, okay, to get strong 0, strong 1, depend on the input. 0, output will be strong 0. Input equal to 1, output equals strong 1. Okay? But in general case for transmission gate, we have control signal here. So we have control signal to turn it off the transmission gate or turn on the transmission gate. So for one, for C equal to 1, no problem. The transmission gate will be on and the output will be equal to input equal strong, 0 or strong 1, no problem. The problem here in transmission gate is when C equal to 0, the N channel is off, C bar equal to 1, so P channel is off. P channel off and channel off, the transmission gate is off. Okay? Here, no circuit here, nothing here. So the wire of the output is on the air, not connected to any VDD or ground. So we call it high impedance and we abbreviate it by Z. Okay? High impedance, high resistivity. Okay? So we have here high resistivity. Did you understand? Any clear? Any question? It's clear. Any question? فهمانين؟ مش الحال؟ Okay, I will stop here. I will stop here. I will not begin multiplex. We have, okay? I will stop here. Any question? Any question?
No, doctor.
Perfect. Perfect.